Hi guys, so I wanted to go ahead and go over some of these practice problems so you can kind of see how to do them. I'm going to try using this stylus, so kind of see how this goes, okay? Um, so when you're doing dimensional analysis, I really encourage you to go ahead and write it in the format I'm going to show you here because I think it's much easier to see how your units cancel and you're much less likely to go ahead and make a mistake. All right, so when we go ahead and take a look at this, how many miles will a person run during a 10-kilometer race? So we're going to go ahead and start here with including our 10 kilometers. Okay, now I like to go ahead and put a line under this so that I realize that I'm going to be using it's kind of set up like fractions. And for this particular one, I'm going to be using this conversion right here. Now, if I'm going to do that, I have to make sure my kilometers cancel. So I want to go ahead and put down here 1.00 kilometers. And then up here, I'm going to put 0.621 miles. Okay. Kilometers are going to cancel, and I'm going to be left with a number in miles, and it asks for miles. Okay, so then you can go ahead and use your calculator. This one's easy to do in your head. So we move the decimal one place, and this ends up being 6.21 miles. Okay, so this is how I'd like you to go ahead and set them up so that you can see really clearly that your units are canceling because we're really focusing on dimensional analysis to help you keep track of your units. As we get further along and start looking at linear motion, we start looking at forces, we're going to do a lot more of this kind of unit canceling, and we need to make sure that we have the right units to get where we need to. Let's go ahead and try the next one. Okay, the moon is 250,000 miles away. How many feet is that from Earth? Well, let's go ahead and start here with our 250,000 miles. Okay, again, we draw the line here. We go ahead and do our dot for multiplication. And we want to go ahead and get to feet. Now, with miles, we don't need to go ahead and do anything in terms of conversion to metrics. So I'm going to go ahead, draw my line here, and I'm going to go ahead and use this conversion. 1 mile equals 5,280 feet. So we've got our 1 mile and 5,000. Let's try that again, 5,280 feet. Okay, mile cancels, and we're left with feet. This one I'm going to actually use the calculator for. So 250,000 times 5,280 feet. And that gives me an answer of 1.32 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the ninth feet. Now, I've written it here in scientific notation, and we're actually going to go over sig figs and scientific notation at a later date. But you can go ahead and do the math on that. That ends up with 132,000,000,000. Okay, just writing it in a little bit of shorthand as you go through. And if you already know scientific notation, I would encourage you to go ahead and start using it. Okay, let's do one more just to make sure that you guys know how to do this. Again, I would encourage you to do this on a piece of paper and take a picture and turn that in rather than going ahead and typing all this in so that you can actually do the crossouts because I do really want to see you do the crossouts as you go ahead and go through. All right, so the average American student is in class 330 minutes per day. How many hours per day is this? So I'm going to go ahead and do my 330 minutes per day. Now you see hopefully why I went ahead and did the lines the way I did in the earlier ones. And we need to go ahead and convert this to hours today. Now, hopefully you recognize that 60 minutes is 1 hour. Minutes cancel, and we're left with hours per day. So that's going to go ahead and make this pretty easy. We can go ahead and cancel our zeros. 6 goes into 33. Let's see, what is that? 5.5 hours per day. Okay, I might as well fill out these top ones. And I can go ahead and post a key for this tomorrow or the next day so that you guys have this to compare your answers to. How many seconds are there in 1 year? Whew, 1 year. So let's go ahead and give this a try. We've got 1 year and we want to convert to seconds. Now, a year has 1 year, 365 days. 1 day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. Minutes cancel, hours cancel, days cancel, years cancel, and we are left with an answer in seconds. And so if we go ahead and do the math on this, 365 times 24 times 60 times 60 is 3.1536 times 10 to the 1, 2, 3, 4, 5, 6, 7, 10 to the 7th. And don't forget your units. You have to do units, and this is in seconds, okay, because we canceled out year, days, hours, and minutes, leaving us with the unit of seconds here. Okay, so this is the basic process I want you to go through as you're doing dimensional analysis. So if you have any more questions beyond that, please come see me. I'd be more than happy to go ahead and go over it with you. All right, take care. Bye-bye.